Hello everyone, my name is Mourad Farhan. I am from Yemen. I am a PhD student in Hassan University of Settat. It's a pleasure for me to share with you my study, which is the total comparison of automatic and manual methods for analyzing heart rate variability parameters, which was carried out in our laboratory radiation meter instrumentation in Hassan University. The heart is the first and the most important vital organ. It's located in the thorax between the two lungs. The contraction of the heart is caused by the propagation of an electrical impulse. The electrical activity of the heart ECG is a physiological signal that can be recorded in a simple, non-invasive way and with accessible and widely available means. ECG signals can be collected by placing disposable electrode on specific area of the human body, such as the skin surface of the leg, arms, and chest. The electrodes are connected to an ECG machine by lead wires. The electrical activity of the heart is then measured. The ECG provides heart rate and their rhythm. From the ECG signals, we can know several features, such as heart rate, which define the number of beats per minute, and heart rate variability. It is by definition the time interval between the successive heartbeats. The figure shows first peak and the second peak. The time between these two peaks is the heart rate variability. The main aim of this study is validation of automatic analysis by comparison and manual analysis of heart rate variability by an operator, which in the future will allow to work on many patients for long time, reliable and reproducible recording period. In the old version of the program was only used to extract signals, but in the last version, a feature that especially in heart rate variability analysis has been added. The study included 10 volunteers. ECG data were taken in the sitting position from the volunteer. The signal was recorded and lead 2 was taken because it gave us a higher air peak than lead 1 and lead 3. For obtained lead 2, we connect the positive terminal to the left leg and the ground to the right leg and the negative terminal to the right hand. ECG data were obtained using PUPAC model MP160 and analyzed by an software acknowledge. Heart rate variability can be analyzed with the different methods such as linear or non-linear analysis. However, the linear analysis includes the time domain and frequency domain. The time domain includes mean of air-to-air interval and mean of heart rate, root mean square of difference between adjacent air-to-air interval, standard deviation of air-to-air interval, number of adjacent air-to-air interval exceeding 50 milliseconds, and normal to normal 50 milliseconds divided by the number of air-to-air interval. Frequency domain, the same include very low frequency, high frequency, and the ratio of low to high frequency. Therefore, in this study, we analyzed heart rate variability with the time domain. The static analysis was based on the difference between the successive R2R peaks, and from this we can calculate the difference parameters. For measure heart rate variability, we use two methods. The first by acknowledge software, which is a software attached with the POPAC. Through acknowledge the parameter RMSSD and SDNN and PNN 50%, we are calculated every 10 seconds. And the second method, we have calculated heart rate variability manually. To check the validity of this result, and this is the purpose of this study, we used the planned Altman plot analysis between the two manual and automatic ways, which allows us to make a comparison between the result obtained and plotted for each parameter, and standard linear regression and Pearson product moment correlation analysis to determine the coefficient of correlation. The first result, we have the agreement of automatic and manual measurement SDNN, standard deviation normal to normal. We have all the points, 95% of the points between the limit superior and the limit inferior of agreement. And the regression, we have R square equal 0.198, and for the second parameters, root mean square air to air peaks, we have the same things, 95% of the points between the limit of agreement superior and inferior, and we have R square equal 0.97 for the third parameters. We have all the points between the limit of agreement, and we have approximately R square equal 1. So from the results obtained, we can observe a strong correlation between the automatic and manual measurement regarding the comparison between the two methods to calculate the same index for a given subject. We observed that the distribution of the means indices of heart rate variability parameters were statistically similar. Planned Altman analysis of all features calculated from the ECG shows close agreement for all parameters. The comparative study shows the evolution of the two methods is similar, and that the automatic analysis software acknowledge is reliable and can be used for the analysis of prolonged recording in the research or in clinical exploration for diagnostic purpose. And this model can be improved to make prediction for weather amplitude and frequency range describing cardiac disorder and arrhythmia. The current system uses temporal feature of heart rate that can be used to classify and predict ECG arrhythmia signals. Thank you for your attention. And when you have any question, you are welcome.